In September of 2012, we left our home port of Seattle on a trip around the world in our Nordhavn 52 Dirona.
Hello, this is Jennifer and James Hamilton aboard Nordhavn 52 Dirona at the Isle of Gia in Scotland. Today we're going to change the starter in our Northern Lights 12 kilowatt generator. In a previous video where we changed the oil in the generator, we noticed that it was a bit slow to start, and this morning we decided to investigate. So let's go down to the engine room.
All right, this is the 12 kilowatt generator. This is the wing engine, and behind me is the John Deere 6068 main engine. Today what we're going to do is change the starting motor on this engine right here. What happened this morning is, well, in fact, let me start by getting the covers off that. Since it just ran, which means it's a little warm, I want to cool it down. A little bit. There we go. It comes out reasonably well. This morning we had to look at this, and what happened is on the last oil change, we were down here watching it, and it just cranked just slightly longer than you expect it to crank to start. So it kind of caught our interest. And we figured, well, we'll check it out sometime in the future. It's been a couple weeks. This morning, the last time it started, we noticed a little bit slow to start again. Now it's kind of obvious even from upstairs. So maybe we need to check on it. So when you're looking for a starting problem on a diesel engine, general rule is you have a fuel problem. It's not guaranteed, but high probability. So first thing I did is when I came down is I wanted to knock off some obvious items. The first one is fuel filter. It's been freshly changed, so we know the fuel filter is not an issue. Second issue is very unlikely to be a problem, but check on the air filter. Make sure the air filter is not plugged.
Where's the air filter?
The air filter is right in here.
Okay, so it's just inside that case.
Right.
Okay.
And again, nothing wrong with the air filter. Extremely unlikely, but you want to check on the easy things. Next thing I did is, this is the fuel pump here. You can see in past years ago that fuel pump was changed, and so the first thing I checked on when we came down this morning was I loosened off the top banjo fitting here, and then pumped fuel with, this is the manual operation of the fuel pump. And what I'm doing is I'm looking for air bubbles at the fuel fitting here. If there's any leaks anywhere in the system, air can accumulate here, and if I check on that, and if I've got any air in there at all, I know I've got the problem understood.
That's an interesting lever. Is that used to bleed it, or what?
Yeah, that's used to.
Okay.
So if you're changing a filter, you'd pump this to fill the filter and then bleed the air out of here. And in fact, right, technically the bleed nut is there, but I oftentimes just do it right there. And so this checked out, we've got what looks to be a good fuel system. So I believe I've got a good fuel pump. Don't know for sure. I know that I have no air in the fuel lines now. I've got a new fuel filter. So the fuel system, even though I told you that was the rule, the fuel system's actually looking pretty good. No obvious problems at all. We've checked some easy ones out there. One more item that I find quite easy to check is the glow plugs. The glow plugs are heaters effectively inside the engine. There's one right there on number 2 cylinder. And inside the cylinder, those are very hot elements that help ignite the diesel when an engine is cold. They're used as a starting assist mechanism. Strictly speaking, they're not absolutely required on many diesel engines. And in fact, the engine behind us, the main engine, doesn't have glow plugs. In checking the glow plugs, again, not a likely problem, but it's so easy to check that I wanted to do it just to be complete. I disconnect this connection right here. This is what feeds the current to the glow plugs. I put an ammeter between these two, and what I'm going to measure is during the start sequence, when the glow plugs are on, I'm going to measure the current flow to the glow plugs. In this case, it's just under 16 amps, which is quite a bit, and that's about right for these. Each one of these 3 glow plugs is about 5.25 amps. So that tells you that all the glow plugs are working fine, not a problem at all. So I'm going to plug this back together. Good and tight, no problem. In the approach we took this morning, the next thing we checked was the starting system. I'm going to be looking for weak battery, poor starting RPM caused by weak battery or bad connections over to this or some other issue. So that's what I'm going to investigate. But you know, before I start with that and show you what I did this morning, what I should comment on is whenever I start a job on any mechanical system, I always want to have a visual look to see what I can learn. You know, what do we know about this engine? And from the oil change previously, when we were talking about it, we noted there's a little bit of powder down below the raw water pump. This is the coolant pump that pumps seawater from outside the boat through the heat exchanger and back out again. This is what cools the engine. And what this tells us is if you look right in there, you'll see the water seal is just got a little bit of white debris around it. What's happening?
Oh, yeah, I can see that. Yeah.
What's happening is it's leaking slightly. That seal's leaking slightly, and salt water is drying around it, and it's making this powder. It means that pump should be replaced sometime in the future. It's not really a rush. It's not leaking any water. There's no spray around it. What I always look for is any spray around it. Nothing at all. So that's fine.
How long would you expect that pump to last?
From this point or in total?
In total. Well, either one.
it really varies greatly. It depends a lot on the cleanliness of the water. It seems like sandier water tends to wear them more thoroughly. Some seals tend to fail earlier than others, and so I have a hard time putting a real accurate time on it. Generally, what I do is usually what happens is they either start leaking oil or they start leaking water, depending on which seals go first. And the cause is the same for both. It's bearing failure. And so at that point, I'll change them. These pumps are completely rebuildable, but I choose not to rebuild them. This is probably the third pump, maybe the second. So that means we roughly get 2,000 hours on them. So I find it's not really a big cost item for us, and so we just go ahead and change that whenever it needs to be done. But I don't rush to do it. Like right now, it's not perfect, but it's fine. I'll change it whenever it becomes a little bit more serious. So I view that as a non-issue.
And remind me, how many hours are on the engine again?
This you probably remember better than me. I think it's 6,600 hours.
Wow, that's getting up there.
It is getting up there. Not bad at all. Although not as good as this one with over 10,000.
Yeah, 10,900, almost 11,000. Yeah.
10,900.
Yeah.
No, that's pretty cool. We'll have to celebrate when it hits 11,000. Especially amazing when you look at how few parts that one's consumed.
It's been incredible. Yeah, it's amazing.
Totally.
We have all these spare parts that we'll just probably never use. Hopefully.
I view that as good news.
Yep.
So what we've got is a largely clean engine. We've got a little bit of evidence that coolant pump needs to be replaced, but we have big evidence of an issue right in front of me here. And let's just have a look at that. See the oil on there?
Yuck.
This engine should have no oil around it anywhere. And what that tells you is we've developed a little bit of an oil leak. And in fact, if you look carefully, you can see that it's more than a little bit of an oil leak. It's
That's a lot of oil.
it's a fair amount. It's actually like it could be 10x that, and it wouldn't really be a concern. What's a concern is that when we changed the oil, there was just evidence of a little bit of misting of oil around here, and now there's actually evidence of.
Oh, so it's getting a lot worse.
It's getting, yeah. So what bothers me about this is a problem that's worsening relatively quickly. Mm-hmm. And what it is it's a rear main oil seal. That's the seal on the back of the engine that's inside here. Mm-hmm. It's leaking oil around the crankshaft into the bell housing area. And then the fan.
And the bell housing is that big chunk of metal?
It's right here.
Yeah, okay.
And then from the bell housing area, the fan that cools the generator is blowing it out, and so it's
so it's spraying it everywhere.
It's kind of unfortunate where it's really a remarkably small amount of oil. Like if you look at how much is missing in it's very close to full.
Can you point to me where the fill line is so I can see it?
Yeah, the fill line's right there.
Okay.
And so it's down. That's the empty line. So it's down about a quarter quart.
So it's actually that's a lot more down than you'd expect in that period.
Not really. When we changed the oil, I gotta watch myself. This is quite hot. When I changed the oil, it was only about to there. So it's down a little bit, but not really very much at all. So. Yeah, it's leaking. The annoying thing is it makes a mess. It's not going to hurt the engine in any way. But I like if you look at that engine, it's nice and clean. In fact, all the engines here are nice and clean. If we let this one keep leaking the way it is, it's going to make a mess. So unfortunate.
And they won't see other problems happening either.
There's lots and lots of reasons why you don't want deferred maintenance to build up. It tends to hide other things, as you said. Unfortunately, this is not an easy one to fix. What has to be done is all of this has to come off. The generator section has to be removed from the engine to get access to the back of the motor, and then the seal has to be changed in there. So for a highly skilled technician that works on them all the time, I suspect it's probably a little bit less than a day, maybe a full day. And I'm guessing for me it would probably be day and a half, heading for 2 days probably. So
you're really looking forward to that.
You nailed it. Yeah, not exactly what I want to do, but I got to tell you, I mean, I hate seeing oil on this engine, and so when I open that up and see that, it makes it harder to work on. It's just unpleasant overall, and it's too bad too, because it's one of those things where a rear main oil seal, I do see them fail, but they're not that common. Oftentimes, usually they just go the life of the engine. So a little bit unlucky on that perhaps. The causes of it. For sure, if the motor has been overheated, or if the compartment isn't cooling properly, or if the engine room is too hot, it can cause seal problems. I've checked the temperatures on this carefully, and it's not a problem. And so it looks like we're just a little bit unlucky on that.
Oh well, we're mostly pretty lucky with these things. So
we are. So you take what you get and move on. So now what we need to do is we need to get to what's the testing I did this morning to determine that there's a high probability that we need to change the starter, and why we're going to change the starter. And so what I did is I opened up the junction box in here, and these relays across here is the start relay, run relay, and the preheat relay. So what I'm going to do is I'm going to take the start relay, sorry, I bumped you there. I'm going to take the start relay out in order to allow me to crank the engine without starting it. For engines that are equipped with auto start, especially for engines that are equipped with auto start that don't have manual controls, you need some way convenient at the engine to be able to crank it over. I've come up with an expedient little trick it's actually kind of fun. I think it's kind of a cool idea. And that is, this is the start relay. And what I've done is I've taken a new relay, pulled the cover off of it, and I use this as a start mechanism.
So have you done anything to the relay? Is it just a stock relay?
It's just a stock relay. It's not designed for Northern Lights. It just happens to be the same functional design. And what happens when you turn the key, you energize this coil, which causes this to pull down and sends voltage to the starter assembly. So the starter solenoid gets driven from this. So what I'm going to do is use this as effectively as a manual start mechanism. So it's really nice. Just unplug the relay, plug that in, and you can see you can just start it by just touching it like that.
And do that again? Oh, that's amazing. That's really cool.
It is. And what I have what I have here is, this is an optical tachometer. I'm going to check to make sure that I'm getting good cranking speed on the generator itself. But what I just heard, I didn't like much, and so I'm going to listen one more time. And we know we're turning slowly, and so for sure we're turning slowly. The most common cause for slow turning is low voltage. And so I've checked voltage of the battery, it's fine. It's very commonly the case that when a battery is very, very low in capacity, if you check the battery with a voltmeter, it checks fine. But in fact, the moment the starter is turned on, the battery voltage goes way low, and so it can fool you. You can check it. If it's a 12 volt system, you'd say, okay, it's 12.4 volts, and seems fine. If you were to put a starter on, like I just did right there, it might drop down to 9 volts or 8 volts. That's not going to start the engine very well.
How much should it normally drop down? Like, it's going to drop down a bit, isn't it?
It will drop down a bit. I'm more used to 24 volt systems, but on a 12 volt system, if it goes down as low as 10, it's fine. A little bit lower than that's probably okay. If it's anything lower than 9, it's terrible. And I guess on a 24 volt system, I would use numbers like shouldn't be much less than probably about 19. And it's just rough rules of thumb. So the testing I'll do is I'll first check voltage at the starters, make sure it's fine. It is. Then what I'll do is I'll get a voltmeter out, and this is all the current that runs the control systems on here goes through this circuit breaker.
Oh, okay.
So I'll check current I'll check voltage right there. That's everything except what goes to the starter. What goes to the starter will be through a very large, probably about a 1 gauge, maybe a 0 gauge wiring harness. The last test is a little bit difficult to get access to in the back of the engine, so I'll use this one to describe what's going on, just because this is easier to get access to, and it's actually exactly the same engine, which is nice because it means it's all the same parts, all the same spares, everything else. So what I'm going to do is I'm going to put a voltmeter right on here. That's the power that's being driven to being delivered to the starter. I'm going to put a voltmeter on there to ground on the engine, and I'm going to measure the voltage across there.
And that's the starter right above your hand, right? On the wing?
That is the starter right there. And so just looking at this item, what we'll see is 26.19 volts. And it happens to be that this emergency wing engine and the generator to the other side share the same start battery. And so because they share the same start battery, they'll both show 26.19 volts. So if I were to be working on the other side, which is hard to get access to, I'll see 26.19 volts. Then I'll crank it and it will drop down to 24, something like that. In this case, it drops down to just right around 23 3/4 to 24, in that range. What that tells you is the battery's fine. It tells you the wiring to the starter is fine. And because I'm checking that while starting it, it tells you the starter's not excessively drawing, but it's not cranking fast enough. And so picture me leaning over the side, reading the voltmeter, and we're watching the voltage. That tells us that we've got great voltage. We've checked everything else in the system, and what we're unhappy with is it cranks slowly. And I probably should show you on this one what normal cranking speed sounds like, but that's roughly 3/4 of a normal cranking speed, maybe a little bit less. It'll start and keep starting for a long time, but that's not normal. The starter's not cranking it over properly. So we're not guaranteed that it's a starter at this point, but we know we've got great voltage going to the starter. We know that we've got basically we know we've got good voltage to it while it's attempting to start, and we know we've got a slow turning engine. So highly likely it's a starter. I'll go ahead and change that now.
Okay, I will go get a spare starter for you. It's going to take me a second because it's buried deep in the back of a bunch of other parts, so you'll have to be patient for a bit.
I betcha. Wow, that's a lot of stuff out.
Yeah, we got this big area underneath the stairs that has massive amounts of parts and boxes in it.
Just what are all those parts to your left?
A lot of them are main engine parts. Let's see, what do we got in here? This is for the toilet system, Tecma control panels. This one underneath here is some spare pumps, I think. Bilge pumps, yeah, various bilge pumps. Lots of little parts for the inverter, control panels.
I get it.
Engine parts.
And what's back in there?
So this is the boxes from the very back of underneath the stairs, and this is where the starter is. And so we've got a spare starter in here. So this is our new starter. We've got a new one there.
Good stuff.
And a couple other things. Got another starter in there, another second starter, and what's this one? Oh, that's the second starter. And that is an alternator as well. So here's our new starter, and we'll get that installed.
Okay, well, I get to experience the joy of working on a warm engine, and we'll see if we can't get that changed. All right, returning to my manual start system. It's kind of a cool setup. The way I came up with it is I wanted to be able to start the motor, run the starter without starting the engine. Just run the starter from working around the engine itself. And of course, because all the harnesses are well made, packed away tightly, there's no way to quickly and easily get a jumper cable on there. I actually have changed the starter before on the wing engine, so I've once changed it on here. This is easy to work on. You can jump it just by taking this connector off right here, that one.
Yep.
Feed power into there, and that runs the starter. So it's easy to test. On this one, it's kind of hard to get to the other side of the engine. It's just inconvenient. And so I took the junction box apart. What I wanted to do was to come up with some quick way that I could start it with a jumper, just because it's easier for me to do it. So what I did is I went to the back of the Northern Lights manual, and in the manual at the back is, in fact, let me just drop it down on there. In the manual at the back, there's a wiring diagram. It's really simple, and these are the 4 relays that are in the junction box.
Oh yeah, that's the ones we saw earlier.
Exactly. Yeah. And this is the one called a start relay. And if you look at it carefully, you can see that a ground through the key switch is what causes the start relay to close, which is what feeds power to the starter solenoid. And so now that we know that, what I'm doing as a way of effectively having a helper upstairs running the starter is I'm just closing this relay by hand, and I can see from there exactly what closing this relay is going to do. And so for the price of a $3 relay, I've just taken the cover off of it, and it's now a manual start system for Northern Lights generator.
You could sell them.
Yes, these are now $100 each. They're fine snap-on part. I recommend them for everyone. All right, so let's get rid of all the debris in the area, and I have to get ready to do some real work where I complain greatly because replacing this starter is easy, and replacing that one is well, I've never done it, but I'm guessing it's going to be less than pleasant, partly because we're at anchor right now, and so this generator's just been run. It's running around 165 degrees, and so it's a little bit in the warm side, and there's no access there whatsoever, so it's real tight and kind of inconvenient to work on.
Did you turn auto start off?
Well, that's a good point. That's a very good point. So we look up here. You look up here and you can see auto start is still on, and there's no warnings and no alarms, so there's nothing else wrong with the boat. So on this particular job, of course, on any job, we'll always have to shut off auto start. On this particular job, I've got to do a few other things as well because I need to have the engine depowered. I don't want any electrical power on the engine itself. So let's go upstairs and get this ready to get this ready to work on. All right. Whenever we work on the engine, we have to shut off auto start. And because on this particular piece of work, we're doing electrical work, so I'm going to shut off the power to the engine itself. And I also want to shut off. This is a control that overrides the system that parallels the house battery to the start battery. It should be off right now, but just to be on the safe side, I'm going to close that. Then I'm going to go downstairs, and on the battery disconnect panel, I'm going to disconnect the generator itself. Then I'm going to put a voltmeter across it across the generator to make sure that there's no power to it whatsoever. Since we're dealing with very large amounts of power, and these big cables can deliver a real punch, it's really important that we be depowered entirely. So off and overridden.
Oh, so the yellow light means it's overridden.
It means it's overridden and it won't get paralleled. Okay. Okay, so what we need to do in here is two things. One is this is the generator start disconnect. This is what feeds battery power to the generator. So that last manual switch closing means that there should be no power to the generator at all. I'll check it just as I always would just to make sure, but at that point it's done. Second thing that's important to do in here is I'm going to look at the battery parallel switch. This is the switch that connects. You don't have to worry about it, it's just right down there. This is the switch that connects the house bank to the start bank, and I want to make sure that's off. At that point, the generator should be depowered. Okay, so the last check we're going to do is we're going to check to make sure that the engine actually is depowered. 0 volts on that.
So what are you running the probes between? What are you connecting?
I'm just probing between ground and this breaker for the control system. The last check is, and this is the one that matters, is behind the engine where the starter is. This is the same engine as this one, and so we can use this as an example. I'm going to check between ground and the starter positive connection, and you see it says 26.20. That says this is a live engine. It's not disconnected. If I were to see that over here, I'd know I haven't done something right. So I'm going to check that now. If that gets 0, then I'm ready to do the starter change.
Okay.
All right. This is like many jobs, many mechanical jobs. This one is mostly preparation, mostly testing and preparation. It takes time to get all that done. The actual job itself, you're not really going to be able to see it because I'm going to be working over top of the engine, and there's only about this much clearance between myself and the wall. And if I gain much weight, there won't be room for me. So it's tight in there, but let's show on this one what we're doing. The actual job itself is remarkably easy. It may be a little difficult to get some of these connections off, but really not very much at all. So what I'm going to do in there is I'm going to loosen off this connection right here and take the battery positive connector off there. And
which is the battery positive? That's the red one?
That's this red one right here.
Okay.
That's probably a 0 gauge.
Mm-hmm. It's a big wire.
It's a hefty wire. Many hundreds of amps flows through this. So I'm going to take this. This nut's going to come off. All these wires are going to drop away. Then I'm going to pull the solenoid wire off of there. That just pulls away. Then I'm going to undo this bolt, which is both one of the bolts holding the starter on. In addition, it's also the ground connection. On the generator, it's not the ground connection. The ground connection on the generator is into here, so I won't have to move this when I'm doing the work. I'll just have to take this one off and that one off, right up there. That's a little bit more challenged. Not really. They're both pretty easy to get access to. And then the starter itself slides out. I'll lift it out, and then we've got a new starter right here. So let's have a look at what a new one looks like. The first important point, at least for marine applications, is we're at anchor in Scotland. It's nice to have the parts so that we're able to do this job today and things go well. This particular part's been in storage for 10 years, and that's the part that's important. Is it's super easy to not maintain your spares well enough, and Jennifer does a super good job of having these packed away well and well sealed from moisture.
Thank you.
And so here's what we've got. See, there we go. And so this is a 10-year-old starter, and you can see
it looks brand new, like it's supposed to look.
It looks brand new. It's wonderful. And
not a bit of rust or anything on there. That's
right. So this is what's going to go on there relatively soon. Well, we'll see if it's soon.
We hope it's soon.
It depends how much work it is or how much difficult it is to get access to the other side. But that's the plan. I'm going to go and get this far side off of here.
Oh, you're getting the back panel off?
Yeah. And it's relatively heavy, so I don't really even like to lift it out of there, particularly if I can avoid it. I just like to lift it out of the way.
Oh, just to give yourself a little more space in the back there. Yeah.
Correct. It's remarkably snug in there. You can see there's little bits of dirt back there, but generally not too bad.
That's a nice package.
Yeah, I used to have a drawer full of stuff, and I so much prefer to do it this way.
Oh, you're just trying to find the right size because everything's the same on the other engine.
Yeah,
That's convenient.
I'm a little bit of a cheater in that it's hard to get access over there, and so I like to find out what size tool I actually need before I get back there and do the work.
Cheating's okay. Unless you're writing an exam, but we're not writing an exam.
I'm not sure I need it, but could you do me a favor and get me the half length of that extension?
Yeah, sure. 1 sec. Is this the one you want?
Yeah. Yep, that's it. That is it. Last check here. That's good. Okay, so I've got roughly what I need to do, or at least the first start of what I need to do to get back there. There comes the solenoid. Wires off. And I'm being punished for cheating in that it feels like that bolt is actually a different size on this one.
Oh, nice.
Yeah.
Do you want me to try to get you a different size, or you're going to have to get out yourself?
I think I'm fine for now. We'll just see how this goes. You can see little bits of oil over there in here, just because from that leaking rear main oil seal, which I find disappointing.
That was tight.
That hasn't been off for 10 years. Almost got that one bolt off. There we go, there's one. The next one is harder to get access to. Well,
That looks like an easy place to work.
yeah, this is not the one that I love doing, to be sure.
This is usually about the time that Spitfire, our cat, shows up and wants to get in the middle of things.
Yeah, I'm surprised we haven't seen him yet. What I'm trying to do here is just, I'm more or less working by feel. So I'm just trying to find that connector and that fastener and see if I can't get it an angle on it. Close.
Great.
There we go. Wow, that is unpleasant. That is the starter. It's hot enough that I'd actually get uncomfortable holding it there.
Takes a while to cool down, huh?
It does. It's just been running very recently. Mainly because the generator is supplying power to the boat, and so it shuts off. We'll run on batteries for a while, but I want it to be but it'll need to come back on another few hours. So, ready to go. I'm fortunately dripping sweat here.
you
not,
look good.
not because it's hard, but because it's a 165-degree engine. So, we're ready to go on that one, and I'll just get the new one.
Can you see anything? Is there anything you would be able to see obviously wrong with the starter? Like, is there anything you can look for? Or?
Nope.
Yeah.
I mean, there's things you can look for, damaged teeth, things like that, but it looks fine. No evidence of any issue at all, other than we're getting very slow cranking. So I'm going to go back in there and see if I can't finish this off.
Okay. Is there anything you need? Any more tools or anything?
Nope. I've got exactly what I need back there, so it's just a matter of wedging back in and getting it done.
Okay. Well, good luck.
Thank you. Okay. Let's get in there. That's a tight spot.
Yeah. Did you manage to not drop any tools in there? That would have been a pain.
Oh man, it's sweaty. There's still a couple tools left in there, but they're not going to be hard to get.
Great.
Just one more pass here. That is snug.
That's a nice bright light.
It's amazing, I find that nothing makes a tight spot seem bigger more than a really bright light. And this Milwaukee M18 light is just it's just amazing. It's like daylight back there, which means it just makes it so much easier to work, especially if your eyes aren't as good as they used to be. So it makes a really big difference. Okay, I'm gonna go wipe up. I'm gonna get some Simple Green and just wipe up that area so it's nice and clean, since it's an area that I normally never get to.
Well, it doesn't look any easier to get at from this angle.
No, there's no angle that you're gonna love on this one. I don't go too crazy, but every time I've got something open, I like to give it a little bit of a wipe down just to make it easier to work on next time.
Trying to see if I can see the starter in there. Actually, I might be able to. Can you lean over again? I know you're just dying to lean over again. Let's point to the starter.
Right there.
Okay, yeah.
And so what I'm going to do now is lift these covers back in place. So watch yourself. All right, so we're getting pretty close to showtime.
Get that out of your way.
First thing I'm going to do is put on the generator battery.
Okay.
So that's now connected up to power.
So the generator is now powered.
So the first thing you check for is smoke, no smoke, and no heat on the starter. It sounds crazy to say that, but years ago I was a professional auto mechanic. I changed the starter on a Chevrolet and was just hooking the batteries up with a brand new starter. When I dropped the negative terminal onto the battery, everything melted instantly. The starter had a direct short inside it, and 1,000 amps instantly just dumped through the whole system.
Oh wow, that must have caused a lot of damage.
It did cause a lot of damage. The trick is get it off there quickly.
Yeah.
So looks like we got a good system here. I'm going to use my handy dandy starting tool just to make sure we got good cranking speed. Let's ready?
Yeah.
Oh yeah.
That sounds way
Oh yeah. There we go.
Excellent.
There we go. So
That's
then,
your $100 Northern Lights manual starting tool.
yes, that's it. That's it. You can get it mail order from here in Scotland. Yes, indeed. Okay, and so I'm going to put that relay back on there, and then we're basically ready to button this job up entirely.
Oh, that's great.
And that's a success.
Awesome. Well, thank you very much.
Thank you for the help.
No problem.
Okay, so I just clean up anything I've been working on. It's relatively clean already, but just to make sure next time it's good to get to. That's on there. Top of the junction panel.
Oh, yeah.
My favorite little tiny screws with my big hands.
Oh yeah, they're just really fussy.
Exactly. They're all four started now, so then just to run it down.
What's this little U-shaped thing? And I keep kind of getting in the I keep getting that in the frame.
It's an anti-siphon valve at the top, and it's to prevent, because this is below the water line, they want to get this up above the water line with a siphon break at the top, so that you can't siphon outside water into the boat and actually potentially sink it.
I see.
So it's,
As well as probably destroy the generator.
well, it'd be hard on the generator, but it's a bigger problem than that.
You'd be happy to just destroy the generator.
Exactly. It's one of those problems you read about and hope you're never involved.
That's a nice enclosure.
Yeah, Northern Lights did a good job on this, and their new ones are even better. They're just as nice, but they're smaller.
Also take up less space.
Yes,
then.
so that means the generator as a whole takes up less space, which sounds nice by itself, but the generator taking less space means there's more room for service.
Yeah.
And that sounds better than nice.
Yeah, like just what you did there would probably have a little bit more space.
Exactly. That's a done job.
Excellent.
Oops.
Oops. I think you
Boat's
need a
move-
break.
No, well, it's partly it's the boat's moving a little bit out there, but
It
it's
is
also
actually,
partly,
yeah.
I think, working upside down over that might have made me a tiny bit dizzy.
Yeah, well, you get to take a break if you want one.
Exactly.
Okay,
And
great.
the key is, we got it done before the generator needs to run next time.
Very
so
nice.
We're good. We're
Great.
operational.
You can read more about our trip around the world at mvdirona.com, including an interactive map showing our track with a live update of our current location.